Okay, so this is Calc Prep 4, word problems. We're going to work through example 2 in these notes. It says a right circular cone has a height of 10 centimeters and a base whose diameter is 6 centimeters. And so we can say that the radius of the larger cone is 3, half of 6. Another cone is placed inside the original cone so that its vertex is at the center of the base of the original cone and so that its base is parallel to the base of the original cone. Now what they're wanting us to do is to express the height on the inside of the cone in terms of the radius of this smaller cone. And we need to come up with two similar cones that are the same shape but not the same size. And this smaller cone here is not necessarily similar to the larger cone. However, there's a third cone, and that is, I'm going to trace it here in blue, it's this cone. This cone right here is similar to the larger cone. So what we need to do is really, and these two cones have the same radius, they don't have the same height. So how can we express the height of this top cone? We can express it using 10 minus h. Right, 10 because it's the total height minus h because it's this segment down here. And so now I have this top cone that is similar to the larger cone. So let's set up a proportion. The height of the smaller cone, 10 minus h, over the larger cone's height should be proportional, or is proportional, to the radius of the small cone, which is r, over the radius of the larger cone, which is 3. And what we need to do here is we need to get height in terms of r. Okay, so we need to basically solve for h. So the way we do this, we cross multiply. So I'm going to go ahead and distribute that 3, and I'm going to get 30 minus 3h equals 10r. I'm going to say that this is negative 3h is equal to 10r minus 30. And this r kind of looks like a v, it's an r. And then I'm going to divide everything by negative 3. So my height ends up being negative 10 thirds times r plus 10. And there are other, you could get a common denominator, but this is the answer to part A. All right, part B says, what is the radius of the inscribed cone if its height is 7? All right, so now what we need to do is we need to use this formula, and this time we're plugging in the height, which is 7, equals negative 10 thirds r plus 10. Okay, so subtract the 10, we get negative 3 is equal to negative 10 thirds r. And now we need to multiply by negative 3/10, and you get r is equal to 9/10, or you could put that as 0.9, or you could even change the units if you wanted, but this is fine. Okay, now let's look at number 3. Number 3 says a wire 24 centimeters long is to be cut into 2 pieces. One is bent to form a square, and the other is bent to form a rectangle, which is 2 centimeters longer than it is wide. Using a single variable, write an expression for the sum of the areas of the square and the rectangle. Okay, so let's draw. First, we've got our square. Okay, and let's just go ahead and label our square as x, and then all of these would be x since it's a square. Okay, now we have a rectangle. Oops. We have a rectangle, and the only thing we know about this rectangle is that if it has a width, then the length is going to be w plus 2. So let's just write everything down, because what we're talking about here is perimeter. And we know that this is all going to add up to 24 centimeters. Okay, so let's add it up. That's going to be, over here we have 4x plus, we have 4w plus another 4. So I'm just adding up all the segments, and now I have an equation, and it's not in terms of one variable, it's in terms of 2 variables. Okay, it says using a single variable, write an expression for the sum of the areas. And so we'll get to the areas part in a minute. But what we need to do is either solve for x or solve for w. This was the information that was given. The perimeter was given. We wrote an expression, and now we need to put this down into one variable. I think it's probably going to be easier to solve for x here, and then and then plug in an expression in terms of W for X instead of having to plug in. It's going to create less work for us. Okay, so one thing you might be looking at is, hey, I can divide everything by 4, and that would be really nice to simplify your problem just a little bit. Here we go, 6. All right, and so that is 5, and if I'm solving for X, if I subtracted over the 1, I would get 5, and then I would also need to subtract over the W. Okay, so now I have an expression. I used what was given to come up with one variable situation. So this square, if we wanted to redraw it, we would redraw it where 5 minus W was each side. Okay, so now I'm going to switch colors just to signify the second part of the problem. Now we're talking about the sum of the areas, okay? So we need to do the area of the square, that doesn't look like a square, plus the area of the rectangle. All right, the area of the square in terms of W would be 5 minus W squared, and the area of the rectangle, we already knew this from the very beginning, would be W plus 2. So you can see that if I had actually solved for W here, I would have had to plug in 2 different things. It's really not that much harder than the original problem. So this is my answer. You do not need to simplify this. And from here, you could answer a lot of questions. You could find the maximum area or maybe minimum, depending on the problem. We're not going to do this. All we had to come up with is the expression this time. Okay, we're going to finish this worksheet in class, and so if you have questions on either 2 or 3 or any of the other ones, bring your questions to class.